Okay, today we're going to be attempting some step 1 integrals. So let's give this a go. So our first integral is the integral from 1 to e of the natural log of x over x squared dx. And so because I have two functions being multiplied by each other here, I think I'm going to have to use integration by parts. So if I make u equal to ln x, that means that my u dash is going to be 1 over x. If I make my v dash equal to 1 over x squared, which is x to the minus 2, that means my v is going to be equal to the integral of x to the minus 2. So that's going to be x to the minus 1 times minus 1, so minus 1 over x. And so this is going to be my u times v, which is minus ln x over x, evaluated between 1 and e, minus the integral of my v du. So it's going to be minus 1 over x times 1 over x dx from 1 to e. We can evaluate this later. And so I can bring that minus sign out. 1 over x squared dx. And so this is going to give us ln x over x, 1 to e, plus the integral from 1 to e of x to the minus 2 dx. And so this becomes minus ln x over x, 1 to e, plus, integrating this, it's going to give minus 1 over x, 1 to e. So let's evaluate this. So we're going to have minus ln e over e plus 0, because the natural log of 1 is 0, plus minus 1 over e plus 1. So this is going to be minus 1 over e minus 1 over e plus 1. This is going to be 1 minus 2 over e. Okay, that's the answer to our first integral. Our second integral, we're going to have the integral of cos x over sine x multiplied by 1 plus sine x dx. Now, immediately I'm thinking, how can I get rid of this square root? Well, I can use a substitution. I can let u squared equal 1 plus sine x. That means 2u du by dx is equal to sine x differentiates to cos x, which implies my dx is going to be equal to 2u du over cos x. And that's lovely because I can see that already that my cos x is going to cancel with my cos x on the numerator. So this is going to become the integral from, oh, well, we don't have any bounds. Recall that if u squared equals 1 plus sine x, then u squared minus 1 is just sine x. I'm going to have u squared minus 1 here, multiplied by the square root of u squared, cos x, 2u du. Cos x goes. So now I get here the integral from 2, no bounds again, multiplied by u. Bring the 2 at the front, 1 over u squared minus 1. I notice this is a difference of 2 squares. So I invoke the I invoke partial fractions, sorry. So, well, I know it's going to be something u minus 1, u plus 1. if I put a 1 here, I think that's almost correct. But I'd need, so that'd be u plus 1 plus u minus 1. I'd end up with, I think this works. Two u plus 2. Well, actually, no, I think doing this works. Minus, because then I have minus u plus 1. Yeah, and then I have to divide by 2 to get rid of the 2 that I get. Okay, nice. So then I'm going to have the integral of 1 over u minus 1 minus 1 over u plus 1. And this is simply the natural log of the absolute value of u minus 1 minus the natural log of the absolute value of u plus 1 plus c. Using our rules with the logarithms, we can write this as u minus 1 over u plus 1 plus c, absolute value again, because we know that log of x is only defined for x greater than 0, right? And what's u? U is just going to be the square root of 1 plus sine x. So root 1 plus sine x minus 1 over root 1 plus sine x plus 1 plus our constant of integration. Thanks for watching.